Welcome back. In this module, we are going to do a quick review of the fundamental characteristics of sensors, the things that define how well a sensor actually does its job. You can see the list on the screen: accuracy, repeatability, drift, response time, resolution, sensitivity, and hysteresis. Now, we are not going to rush through all of these at once. Each one deserves its own moment, but in this lesson, I want to focus on the first two, accuracy and repeatability. Because honestly, these two get confused all the time, even by experienced engineers. And once you really understand the difference between them and the relationship between them, a lot of things in instrumentation start to click. So let's get into it. First up, accuracy. The formal definition is simple. Accuracy is how close your measurement is to the true value. That's it. How close are you to the real answer? The slide gives a great example. Say the actual pressure in a pipe is 100 psi. That's the real true value. And your transmitter reads 99.5 psi. That's only half a psi off. That instrument is very accurate. Now, one thing you will see a lot in data sheets and spec sheets is that accuracy is expressed as a percentage of span, something like plus or minus 0.1% of span. So, if your instrument has a range of 0 to 200 psi, that 0.1% means your readings are within plus or minus 0.2 psi of the true value. Small number, but meaningful, especially in critical process. The key idea here is accuracy tells you how close you are to ground truth. It's your reference against reality. Now, here is where it gets interesting. Let me ask you something. Imagine you measure the same process variable, say temperature, 100 times, under the exact same conditions. Do you get the same number every time? That's repeatability. And notice, I didn't say the correct number, just the same number. Here's the example on screen. A temperature sensor that always reads 101 degrees Celsius when the true value is 100. Every single time, 101. It never wavers. That sensor is highly repeatable, but it's not accurate. It's consistently off by 1 degree. Now, look at the 4 target diagrams on the slide. This is one of the best visual tools in all of instrumentation. So, I want you to really take a moment with it. Accurate and repeatable. All your shots are clustered tight, right in the bull's eye. That's the ideal. Not accurate, but repeatable. All your shots are in a tight cluster, but they are consistently hitting the wrong spot. Same error every time. Accurate, but not repeatable. Your shots are scattered, but they happen to average out near the center. That's random luck, not reliable measurement. Not accurate and not repeatable. Scattered all over the place. This is a nightmare scenario. And here is the insight that I really want you to take away from this slide. An instrument can be repeatable without being accurate, but an instrument cannot be accurate if it's not repeatable. Think about that. If your readings are all over the place, there is no way they are all correct. Repeatability is the foundation that accuracy is built on. So, now the natural question is, what breaks repeatability? what causes those scattered, unpredictable readings. The slide breaks it down into 3 main culprits, and I want to go through each one because you will encounter all of them in the field. The first one is mechanical slop. Think about loose connections, worn bearings, and the sensor that's not mounted tightly, or backslash in a mechanical linkage. Anytime there is physical play, any looseness in the system, you introduce inconsistency. One reading, the sensor is pushed slightly one way. Next reading, it's shifted slightly the other. The numbers bounce around and you lose repeatability. The fix usually physical. Tighten it, replace the worn part, remount properly. The second is electrical noise. This one's common and sometimes tricky to diagnose. Intermittent wiring, dirty or corroded terminal connections, or electric interference from nearby equipment. Think variable frequency drives, VFDs, or radio transmitters. All of these can inject random spikes and fluctuations into your signal. The reading is jumping not because the process is changing, but because your signal cable is picking up interference. Proper grounding, shielding, and the clean connections go a long way here. And the third is unstable conditions. Sometimes the environment around is changing, ambient temperature swings, vibration from nearby machinery, or even the process itself is unstable, like a pump that's charging. If the conditions aren't steady, the readings won't be either. Before you blame the instrument, always ask, is the environment stable? Is the process actually steady? These 3, mechanical slop, electrical noise, unstable conditions, they are your diagnostic checklist whenever you are chasing a repeatability problem in the field. So to bring it all together, accuracy is about truth. How close is your reading to the real value? Repeatability is about consistency. Do you get the same reading under the same conditions? They are related, but they are not the same thing. And understanding which one you have a problem with completely changes how you approach troubleshooting and calibration. In the next lesson, we will move on to drift. What happens when a previously accurate instrument starts scraping away from truth over time? And how to catch it before it causes real problems. Alright, see you in the next one.